Okay, Algebra 1 fans, today we're going to look at the last part of the notes that we started yesterday. And if you take out those notes, it says Notes Day 39, Solve Systems of Equations Using Substitution and Elimination. So we did most of this yesterday, but we did not get to the last page. So go ahead and turn it to the last page. And we're going to continue with the method called elimination, but we're going to have to use multiplication to do this. All right, so you've got three examples here, 11, 12, 13. At the bottom of this paper, you have a lot of space. At the bottom of this paper, let's summarize what we did yesterday, or one thing that we talked about. If I give you an equation, for example, 3 is equal to 3, okay, which is true. And let's also say that 2 is equal to 2, which again is true. Both of these equations are true equations. What we said yesterday is that if you think of this as a system, you are allowed to add the two equations. And you would get, if you add the columns, you get 3 plus 2, so you get 5 equals 5, which is still a true statement. Okay, so you can add the equations and the equality still remains. If you wanted to, you had a couple examples on your assignment yesterday where if you had subtracted, let's say we subtract the equations. So we do 3 minus 2, which is 1, and 3 minus 2 again is 1. That's still true. You're allowed to subtract the two equations if you want to. Now, what we're going to talk about today, a couple other techniques, a couple other things you can do. Let's say again we have 3 equals 3, 2 equals 2. There's the system. What if we take, let's say the top equation, 3 equals 3. What if we multiply the left side and the right side by 4? Okay, we're going to multiply both sides by the same thing. Now you know that in any equation you can add to the left and right side the same thing. You can subtract, you can multiply, you can divide, and the equality is still true. Now if we do that, 4 times 3 we get 12 equals 12, which is still true. You get 2 equals 2, and if you want to, you could add those up. You get 14, still equal to 14. So this technique of multiplying, we're going to use this today. Let me show you one more example here. Let's say, again, 3 equals 3, and 2 is equal to 2. Let's multiply both equations. Let's take the top equation and multiply by -5. Okay? And let's take the bottom equation and multiply by, let's say, 4, +4. Well, we're not going to add yet. So we get the top equation is -15 equals -15. That's still true. The bottom equation is 8 equals 8. That's still true. If you add them, -15 plus 8 is -7 equals -7. Okay, that's true. So what we're showing here is that you can multiply both sides of the equation by the same number and the equality is still good. So let's go back up here to the top and let's look at the examples. Number 11, 4x minus 3y is equal to 12. That's the first equation, and then -x plus 2y is equal to 2. Now the problem is that if I add these now, I'm not going to eliminate a variable, and that's bad. We're trying to get rid of one of these variables, the x's or the y's, but right now we can't do it with these numbers. So we're going to think ahead. If I look at x, this is +4x and this is -1x. I could put a -1 there. If these, I could get these to be opposites. If I could make this -4, then I could add this to +4 and get 0. So I'm thinking, what can I multiply Here's equation 1, here's equation 2. What can I multiply the bottom equation by that would make this a negative 4? Negative 1 times what gives me negative 4? And the answer is, I'm going to multiply by 4. So equation 1 doesn't change. I'm not doing anything to that. That stays the same. Equation 2, you have to distribute. That's going to be negative 4x. Now that's nice. We're going to get positive 8y plus 8y equals 2 times 4 is 8. Now we can do something with this. These are opposites. So the next step, we're going to add the two equations. We're going to add the columns. 4x plus negative 4x, 0. Negative 3y plus 8y is 5y equals 20. We eliminate the x. Now we can solve this for y. Divide by 5, divide by 5, y equals 4. Now we're not done because we still need to find the x value. Now I can go back to equation 1 or equation 2. It doesn't matter. I'm going to take equation 1. So equation 1 was 4x minus 3 times y equals 12. Now instead of the y though, let's go ahead and substitute our value for y, which was 4. So we're going to put a 4 in there. And now we're going to work this out. We get 4x minus 12 equals 12. Let's move the constant. Plus 12 plus 12. We get 4x, that's just 0, equals 12 plus 12 is 24. Divide by 4, and we get x equals 6. So the answer to our system is 6 comma 4, x comma y. 6 comma 4. Now does it work? Well, you can go back to the top equation here and you can take x was 6, so you could do 4 times 6 minus 3 times y, which was 4. You get 24 minus 12, which is 12. Check. So that's good. Now in the bottom equation, you get negative x, that's negative 6, plus 2 times y, which was 4, negative 6 plus 8, and that equals positive 2. Check. So there's our answer. Okay, so what you're thinking when you do this is, what can I do to eliminate a variable? Can I make these opposite coefficients? That's a positive 4x, make this a negative 4x, and then you multiply. Okay, look at number 12. You have, let's look at the x's and let's look at the y's. So the x's are 2x and 3x. Now, if you wanted to eliminate these, you'd have to think, what is a common multiple of 2 and 3? Common multiple of 2 and 3, well, that would be 6. So you could try to make this a 6x and a negative 6x. The problem is you'd have to multiply both equations to do this. Right? Let's try to stick with one equation here. Look at the y values. Positive 1y, negative 2y. What we're thinking is if we could make this a positive 2y, we're in business, because then we can add these up and they will eliminate. Well, 1 times what will give you 2? Let's take the top equation. Here's equation 1, equation 2. Let's take the top equation and multiply by positive 2. Okay, by positive 2. Now you're going to have to distribute. So we're going to get 2 times 2x, we get 4x, plus 2y equals 10. This is why we practice distributing so much, because now we're really going to use this. Then we have, so that's equation 1. Equation 2 stays the same. 3x minus 2y equals 4. Now look at what we have. Positive 2y, negative 2y. This is exactly what we want. When you have opposites, add the equations. So we get 7x, positive 2y plus negative 2y is 0. equals 14. Divide by 7, and we get 1x equals 2. Now we're not done. We want to solve also for y. Now, if you go back to your equations, 1 and 2, equation 1 is 2x plus y equals 5. Since this is a 1y, I like this. Let's do 2 times x, so that's 2 times 2, plus y equals 5. That's equation 1. So now we solve it. It's 4 plus y equals 5. We're going to subtract 4 from both sides. We get y equals 1. So our answer here, I'll write it down here, x comma y is 2 comma 1. And if you check, it should work. Okay, so what I'm going to do is this. I'm going to turn off the video for a moment. I want you to try to do number 13. Okay, and then we'll come back on and see if we agree with our answers.